Alrighty, class. I just posted a video and I was informed that it had no audio, so I'm gonna try to redo it again. Here we go. Okay. By the way, thank you, Lindsay. All right, so here we go. This is 2.1. Again, I'm going to start by defining the words associated with radicals so that you know how to simplify them or know when I refer to the words, you know what I'm talking about, okay? So the first thing is the symbol itself, okay? So it looks like this. It looks just like a V with a long tail, all right? And there are three things that you need to know about the radical. And that is there's always a number outside. If you don't see it, it's a 1, okay? So there's always a number outside. I'm going to just put maybe I'm going to put a 4 here. This is called the coefficient, okay? And the coefficient is what I call the outside number, okay? So you will hear me refer to outside numbers, inside numbers, okay? So the coefficient is the outside number. And then there is the radicand, which is the inside number, okay? The number inside under the radical root, okay? So there's the radicand. The radicand is under the radical root. I'm going to put maybe put a 12 down, okay? And then there is a third word, which is index, okay? The index or the root, okay? So what are you working with, okay? You need to be paying attention to the index because the index tells you what to do. Okay, so here I don't see anything. Now, when you don't see anything for the index, that means it's a 2. Okay, so that's an invisible 2, but we don't write it because everybody in math knows that the index is 2 when you don't see one. Just like 3 over 1 is 3, but we don't write 3 over 1 unless we have to. Okay, we write 3. All right, so just by standards, if you don't see a number, that means that you are working with the second root. Okay, so normally we don't write it. Okay, so how do you simplify a problem like 4 radical 12? Okay, the first thing you want to do is to break down the radicand, break down the inside number. Okay, so the 4 is good. I'm going to leave it here. And I'm going to break down the 12 into its prime factorization. Okay, so prime factorization. All right, so break down the 12. That's 4 times 3. Okay, and you know you can't break down the 3 anymore, but you can break down the 4. 2 times 2. All right, so the prime factorization of 12 is actually 2 times 2 times 3. Okay, that's 4 times 3, which is 12. And what you are going to do is the benefit of breaking this down into its prime factors or rewriting 12 as the prime factorization of 2 times 2 times 3 is now you can actually simplify the expression for radical 12, which is really 8 radical 3. Okay, so how do we get 8 radical 3? Okay, the index of 2 means look for 2 of a kind. Okay, so here I have 2 of a kind. There's a pair of 2's. Anytime I have a pair of 2's, if I'm working with the second root, that enables me to take one of those factors outside. Okay, so outside I already have a 4. Now because I have 2 of the same kind, I can take one of those factors out. Okay, I can take a 2 out. And once I take that out, it's gone from the radicand. So now all I have left is a 3. And to get my final answer, I multiply everything outside. So 4 times 2 is 8. And you multiply everything inside if there's more than 2 factors. But here it's just a 3. So the answer, simplified answer to 4 radical 12 is 8 radical 3. All right, so this is how you do all the problems. So you got to pay attention to the root because the root will tell you, should I pair them up? Should I put 3 together? Should I put 4 of the same things together? All right. Okay, let's apply that to your assignment. Okay, so I did number 1 in the other video, so I'm going to go ahead and do this number 2. All right, so number 3, this is probably one of the simplest question that you can have. Okay, so you have a coefficient of 3 and you have a radicand of 8. So break down the 8. Okay, so you know the 8 is 4 times 2 and 4 is 2 times 2. So you are going to rewrite 8 as 2 times 2 times 2. And then you are looking or working with the second root because you don't see anything here. That means the index is 2, so you're looking for 2 of a kind. And then you can just pair them up. Okay, so I see a group of 2. If you have a group of 2, you can take one of those out. Okay, so I already have a 3, and I can take a 2 out, and it's gone. Make sure you cross it out. And then inside the radical, I just have a 2 left. To finish off the problem, multiply the outside numbers. That's your new coefficient. And the inside number is a 2. So that is your answer to the problem. Make sure that you go back to the bottom of the page and always check your answers, because you want to make sure that you do this right, and we have the answer. Okay, all right, let's do another problem, something like this number 7 here. Okay, so the first thing I notice is that I see a 3 in the index. So we are working with the third root, okay? The process is exactly the same. So we are going to go ahead and write out the coefficient. We are going to break down our radicand. Say that's a third root. So you must write down the root if it's not a 2, okay? Because if you don't write anything, we already know that's the square root. So if it's a 3, if it's a 5, it's a 4, you gotta write it down. If you don't, your answer is incorrect. All right. So you have 2, and the third root of 24 is the same thing as 6 times 4. So I'm going to do a little bit of mental math here, okay? So 6 is 2 times 3, and 4 is 2 times 2, okay? And p to the third, break it down, that would be p times p times p 3 times. That's a factorization of 24p to the third, okay? Now, third root means you are going to put 3 of the same kind together, okay? So I'm going to use highlights because I did not put this in order, okay? So I have a 2 here, a 2 here, and a 2 there. That's 3 of a kind. I can take one of those out. And don't forget, if you take it out, make sure you cross it out. And then I also have a group of 3 p's here. So I can take one of those out also, okay? So I have a 2 outside, that's from the original coefficient. And then I can take a 2 out, that's for the pink highlighted numbers, the group of 3 2's. And I can take out a p, okay, for those 3 p's. Now don't forget to cross this out once you take them outside. Okay, only 1, not 3, not 2, okay? And then don't forget to write down what we have left. We have left inside the radical, we have a 3, and we are working with a third root. You must write that down. And to finish off the problem, we need to multiply all the numbers outside. And we have to write down our radical expression, and we are working with the third root. So this should be the answer. Please check your answer, okay? That's for number 7. Let's do another one. Let's do this one here, number 12. All right, so here you have a negative outside the radical. That means that your coefficient or your outside number is a -1. And then you are working with the second root because there's no number for the index, so I know it's a 2. And I'm going to break down 8x, okay? So I know that 8 is 4 times 2, and I know that 4 is 2 times 2, okay? And I have another 2 for the other 2, all right? And we have an 8. Again, if you need to break it down all the way, do that. I know some of you need to see it, some of you don't, okay? So you show as much work as you need to, but at least I need to see the coefficient, I need to see the breakdown. And then you can pair them up, 2 of a kind. You can take that outside. Don't forget to cross them out right away so you don't forget. And inside you have a 2 times x. The last step is always to multiply everything outside and multiply everything inside. Check to make sure that you have put the correct root down if it's not the second root, okay? So make sure you include that number. All right, so that's what you have here. I'll do one more problem, this 3, and I'll leave you alone, okay? 13. All right, so again, same step, okay? 3, break down the 16, 4 times 4, okay? If you want to, you can just leave 4 and 4, okay? But I'm just gonna break it down just because some people need to see it, okay? 2 times 2, that's for the first 4. 2 times 2, that's for the second 4. And then you have v times v, that's for your variable. All right, So we want to pair them up, okay? Second root. So there is one pair of 2's, there's another pair of 2's, and there is a, oops, don't want to do that, a pair of these. All right, so I have a 3. That's from the original problem. Then I can take out a 2. I can take out another 2, and I can take out a V. And guess what's inside? It's a 1. Okay, so radical 1 is 1, so I'm not going to bother that, but there's nothing left, although there's really a 1 left. And again, square root of 1 is 1, okay? So I'm just gonna just leave it like that. And if you want to, I can write it down for you, okay? So now multiply all of these numbers. That will give you 4 times 3, 12 V, and square root of 1 is 1. So I am just going to leave it as 12 because 12 times 1 is 1, okay? So this is just 1, all right? Okay, so I'm glad I went over this one. Let's see, anything else? I think everything else should be doable, pretty doable. All right, so hopefully this helps. I will upload this for you momentarily. Thank you.